Welcome, ladies and gentlemen, mathematicians. I am going to cover a little bit about relations and functions and how are they related. First of all, let's talk about the definition. A relation is a correspondence between the first set, which we normally think of as X, or we call it the domain, and the second set, which is our range or our Y values, so that each member of the domain, or our X's, corresponds to at least one in the range. All right, so you can have more than one answer for a member of the domain, like an X can have more than one solution. In the case of a function, it is a correspondence between the domain and the range so that each member of the domain has exactly one in the range. So the big difference here is how many answers can you have. Everything else is the same. There's this relationship from the X to the Y, and you've got, for every X, there's got to have at least one answer. And in the function, it's got to be exactly one answer. So hopefully that's a little helpful. I want to go on to another and see if we can figure out which is domains and ranges and all of that good stuff. So hang on a second here. I'm still learning how to use this stuff. Alright, so on my X and my Y, or my domain and my range, here I have my X is going up by 1, so this starts at 1, 2, 3, 4, 5. And my Y goes up 3, 6, 9, 12, 15. So the question is this a relation? Is it a function, or is it both? Well, how many solutions do we have? Here's my first set, right? My domain, and I have how many in my range? Each one of these has at least one, right? So this is going to be a relation, but it's also going to be a function because it has exactly one, right? We have exactly one. So this is going to be both a relation and a function. Okay, so what about this one? Well, it would have helped if I finished it up, right? Well, let me put in some numbers right here real quick. This is actually what I intended to do. Okay, so taking a look at this, I have my domain, I have my X values, and as I look across my range, every single one of these is 1. Now, the question is, do I have at least one answer for each of my values in my X, or in my domain? And the answer is yes. I have one answer. That it may be the same answer for all of them, but it is one answer. So I've got 3 it has a value of 1, 2 has a value of 1, 1 has a value of 1, 0 has a value of 1. So there is exactly one solution for each value of our domain. So this is both a relation, since it has at least one, and a function, since it has exactly one. Alright, take a look at this one. So I've got a domain of 0, 2, 2, and 0, and a range of 0, 2, negative 2, and 1. Now, if I take a look here, my 0 has two different solutions. Now, if they were the same number, if it was 0, 0, and 0, 0 down here, that's still the same number. That doesn't really count as being anything new. In this case, if this was a positive 2 and this was a positive 2, again, we would say that that's just, we're being redundant in putting it in there, but there's only one solution because it's the exact same number. In this case, that is not the case, right? From here to here is one solution, and from here to here is another solution. So I have 2 solutions here, and I don't need to find any more. Can this be a function? And the answer is no. It cannot be a function because I have, for one of my domain, right? This and this number are exactly the same, the 0 and the 0, has more than one. It has at least one, but it has more than one solution in my range. So in this case, we're done. This is the only thing that this is a relation. Okay, we can say it's a relation, but it is not a function. And again, here I have 2, right? My 2 goes here, and it goes to another number, goes here, right? So again, either one of those would make this not be a function. So we've got a relation in this one. Everything else is a relation and a function, which should give us some idea about how things work here. I have a relation. Well, let me go back to red. This will hopefully help make it clear. My relation is like this big pool where everybody's swimming around, and the functions are something smaller in here. So we've got our function, and then our relation, right? So a function is necessarily a relation, but a relation is not automatically a function. And hopefully that makes some sense. If you're unclear, go ahead and rewind, listen to this again, and then go ahead and ask me questions. I do have one more screen that I wanted to take a look at here and talk very briefly about the what is referred to as the vertical line test. The vertical line test is a test that we can do where we're dropping anywhere along here. We can drop a line vertically. It's that vertical line test, right? So if we drop a line vertically, the only place for each of those lines that we drop, we're only going to cross it once. Okay? We're only going to cross this function once, or this relation once. So if I cannot find anywhere that I'm going to bump into either more than one, or I don't have a solution, then we can say that this is a function. In this case, we would say this is a function. This line right here doesn't have two solutions anywhere. It doesn't have any place that it's broken. So this is a function. Here's another one. We can look at this. Right? Again, we're going to draw our line, and despite my bad artwork, I intend this to be just where it doesn't cross at all. Right? I only have one place that it's crossing on each of these. In that case, it's going to be a function, right? Here's a function, here's a function. And then in this case, when we drop our vertical line test, take a look, here's one and here's another. And this is all we have to do. The only thing we have to do is find one of these where it breaks the rule of when we drop our vertical line, there's only one solution. So this is a relation, but it is not a function because of the vertical line test. So it is not a function. All right, so at this point, I think I'm going to call this video good, and we'll go from here.